The ground doesn't shake the way you expect. It's lower than that. It moves through your feet before your ears register anything. A slow compression that feels more like the planet exhaling than anything breaking. Then the horizon changes color. Not one horizon, all of them. A deep orange-gray bleeding upward from every direction at once, like the sky is being stained from the outside in. The air smells wrong before you can name why. Something chemical, something old. You look north and see a column of ash climbing so high it disappears into the upper atmosphere. Then you look south and see another. Then east. Then west. This is not a regional emergency. This is every volcano on Earth erupting simultaneously. All 1,500 active ones, firing at the same moment. And today, we are going to find out exactly what happens next, starting from the first second and ending at the last thing left standing. In the first few hours, the scale of this becomes hard to hold in your mind. There are roughly 1,500 active volcanoes on Earth, which sounds manageable until you understand that even a single large eruption can push an ash column 40 to 50 kilometers into the stratosphere, high enough to punch through the weather layer entirely and sit directly in the stream of air that circles the planet. Now, multiply that. Not by 2 or 10, but by 1,500 firing simultaneously, plus an unknown number of dormant volcanoes potentially reactivating as pressure redistributes through the crust beneath them. The combined lava output would exceed every historical eruption in recorded history combined by an enormous margin. But here's the thing most people get wrong immediately. Lava is not what kills you. Lava moves slowly enough that a reasonably alert person can walk away from it. What moves at 700 kilometers per hour is a pyroclastic flow, a superheated column of gas and shattered rock that descends a slope faster than any vehicle, and at temperatures that make the air itself lethal. The sky above an active eruption does not glow orange because of fire. It glows because the ash is catching and scattering light from below, and from a distance it looks almost beautiful. From inside it, there is only gray. Every direction, gray. The question nobody is asking yet is what that gray does to the air above the entire planet. Here is where this stops being a local disaster and becomes a planetary one. Volcanoes release sulfur dioxide when they erupt. In the atmosphere, sulfur dioxide reacts with water vapor to form sulfuric acid aerosols, tiny suspended particles that spread through the stratosphere and act like a partial mirror, reflecting sunlight back into space before it reaches the surface. A single, large eruption in the Philippines in 1991 dropped global average temperatures by roughly half a degree Celsius and held them there for nearly 2 years. That was one volcano. Now scale that sulfur injection by 1,500 simultaneous eruptions. The aerosol layer that forms would not be a partial mirror. It would be a significant one. The counterintuitive part, the part almost no one expects, is that the immediate danger from all these volcanoes is not heat. It is cold. The sulfuric aerosol layer blocks incoming sunlight, and within weeks to months, temperatures at the surface begin to drop. Daytime skies dim toward a permanent gray-orange twilight. Sunsets turn colors that have no normal name, deep purples and arterial reds that last for hours. The warmth you associate with a clear afternoon simply stops arriving. The CO2 from the eruptions will drive warming eventually, but that is a slow process measured in centuries. The cooling happens in weeks, and that is a problem because everything alive on the surface runs on sunlight. Within weeks to months, the world goes dark in the way that matters most. Photosynthesis, the process that turns sunlight into the base of nearly every food chain on Earth, requires a reliable supply of solar energy. Reduce that supply significantly, and plant growth slows. Reduce it further, and crops fail. A single eruption in Indonesia in 1815, one volcano, caused summer frosts across the northern hemisphere the following year. wiped out harvests across multiple continents, and contributed to famine conditions that killed an estimated 90,000 people directly. One volcano. The scenario here is not one volcano. Civilization does not end because lava reaches a city. It ends because ash blocks the sun above a wheat field thousands of kilometers away. And then the supply chain that depends on that field breaks. And then everything downstream of that supply chain breaks with it. The cold does not need to reach you. It just needs to reach the soil above your food. The gray skies stretch from pole to pole. Rivers run the color of wet concrete from ash sediment. The quiet that falls over a world without functioning agriculture is not peaceful. While the sky is doing that, the ground isn't standing still either. The physical surface of the Earth reshapes under this kind of sustained volcanic output. Submarine volcanoes, which account for roughly 70% of all volcanic activity on Earth under normal conditions, would heat shallow ocean water locally and release enormous volumes of dissolved gas into the ocean column. New land forms along volcanic chains as lava cools into black rock and extends coastlines that existed the week before. In regions near major eruption sites, ash accumulates not in centimeters but in meters, burying infrastructure, collapsing roofs, and rerouting rivers that no longer reach their original channels. The weight redistribution from material moving from inside the Earth to the surface shifts stresses along fault lines, making significant seismic activity across multiple regions more likely. What is strange about watching this from a geological perspective is that it is not chaos. It is the planet doing exactly what it has always done, on a compressed timescale. Every continent you stand on was built by this process over billions of years. The destruction and the construction are the same event. You are just watching it faster than the Earth usually allows. So, does anything make it through? The answer is yes, but probably not you. Thermophilic microorganisms, organisms that thrive in high heat and chemical-rich environments, would be unaffected and in some cases would benefit directly from the increased availability of sulfur compounds and mineral-rich volcanic output. Deep ocean ecosystems clustered around hydrothermal vents, which run entirely on chemical energy rather than sunlight, exist completely outside the collapse of surface food chains and would continue undisturbed in the dark far below everything happening above them. Large surface animals, including humans, face the compounding pressure of volcanic winter, agricultural failure, and sustained degradation of air quality. The closest geological analog to this scenario is the extinction event at the end of the Permian period, roughly 252 million years ago, linked to prolonged massive volcanic activity, after which an estimated 90 to 96% of marine species and around 70% of land vertebrates did not survive. The survivors were not the largest or most complex. They were the ones that did not depend on sunlight or surface stability at all. The deep, the small, and the ancient outlasted everything built on top. In thousands to millions of years, the planet recovers, and the method of recovery is the same as the method of destruction. Sulfuric aerosols settle out of the stratosphere within years to decades. Skies clear. Sunlight returns. The volcanic ash that buried entire regions is extraordinarily mineral-rich, and over centuries it breaks down into some of the most fertile soil on Earth. Life that survived in the deep, the microbial, the chemosynthetic, moves back toward the surface and begins the slow work of rebuilding complexity. After the Permian extinction, full ecosystem recovery took on the order of 10 million years. 10 million years is a long time by any human measure. By the planet's measure, it is a moderate inconvenience. The volcanoes that burned everything built the foundation. Everything grew back on. That process has happened before. The planet you are standing on right now is the recovered version. Here's the part that stays with you. The ground under your feet is not permanent. It was built by exactly this kind of violence, slowly, over billions of years, and the same process is still running right now. In the ocean floor, in the rifts, in the places where plates pull apart, and the interior pushes up into the gap. Every calm surface is temporary. What makes this scenario feel impossible is only timing. All of it is already happening, just not all at once. The floor you are standing on right now exists because volcanoes built it, and somewhere, very slowly, they are already building the next one. If you want to see more, click the video on screen now.